All right, so thinking about test retest reliability, internal consistency, inter-rater reliability, think of the definition of those yourself. Look in your notes, look in your book, see if you can remember those things. And then I'll give some examples right now. So when we're talking about being consistent with a measure, making sure it's measuring the same thing over and over again, that it's being reliable, one way we can test if it is by using test-retest reliability. So we ensure the scale is consistent by measuring the same person twice. So we measure one person, or it could be one group of people. We give them like a pre-test, and we give them a post-test. Well, I guess scratch that. Rather than calling it a pre-test and post-test, let's say we give them the test once, and then a few minutes later or a few days later, before they've done any kind of intervention, before anything would have changed, we give them the same test again. So an example is you take an IQ test. It should be nearly the same score about 4 months later. So to test if so let's say you've created a new IQ test. You think it's the best one out there, but you want to make sure it's reliable. You want to make sure it's consistent. So you test 100 people with it, and you check what is their IQ score. Let's say the average IQ score of these people was 115. So that was the average for everybody. Then 4 months later, IQ probably wouldn't change very much in 4 months. So it might go up a point if these people are in school, but it should pretty much stay the same. So 4 months later, you give them the exact same test again and see if they get the same score. So maybe the mean score this time is 117. So that would be a pretty good score. That would show that it's pretty consistent, that maybe there is some measurement error, or maybe people are developing a little bit. Other ways you could do this are if you have a test about anger and you want to see if it is reliable. So you give them these 5 questions about anger. You see, okay, person A is very angry right now. Then 2 minutes later, you give them the same test. In those 2 minutes, they should be getting the same score. So you can correlate those scores from the first time you give the test to the retest time, and it should have a correlation of at least 0.80. That's a pretty strong positive correlation, if you remember the linear relationships that you read about and we talked about in the book. All right, so a problem with using test-retest is that sometimes people remember how they answered the first time, and it might affect how they answer the second time. So in other words, using test-retest can sometimes create measurement error. So what's another thing to do? So another way to use test-retest reliability is with alternate forms reliability. So with that, you would be using 2 different, see we've got purple version and yellow version, and you can see it's 3A and 3B. So you use different but equivalent forms of the test the second time. So in the first test, you give form A, then 5 minutes later, you give form B. And they ask very similar questions. They should be getting the same kind of answer. So you should still see a really high correlation of 0.80 or above if your test is reliable. And so that's one way to test with one single person or one single group with a test and then a retest if they have consistent answers. But even then, sometimes the questions could be too similar. So another thing people do is rather than testing and retesting, they do it a single test, and this is called internal consistency reliability. So rather than testing and then retesting, this is only measuring people at one point in time. So with that, all these questions on your measure should be measuring the same variable. So all the questions should be measuring IQ, all the questions should be measuring purpose, all the questions should be measuring anger, those types of things. So one way to do this internal consistency is by doing split half reliability. So basically, it's pretty simple. You split a measure in half, and each of those 2 halves of the measure should have a similar score. So they've only done the test one time, And their score with the even numbered questions should be pretty similar to the score on all the odd number questions. So that is split half reliability. And I'll show you an example of that here. So here we have the Claremont Purpose Scale again. The split half coefficient in this case, we found a 0.93, which is very good. And the way we did that is this was 6 items long. So we see these blue items, 4 people got these scores. And the red items, so we split it in half. So blue was 1/2 of the test. Red was the other half of the test. Again, we only gave them all these items one time. It wasn't like they did blue first and then red later. They did all these questions at the same time. And for these 4 people, they got pretty close to the same score on a lot of these on these items. So the coefficient was very high. So we split the measure in half, and you wouldn't have to do it odds and evens. You could do the first 10 and the second 10. You could split it any way you want, and that is split half reliability, or a split half reliability check. So a problem with that is, well, it's kind of dependent on where you split the half. Should you use every other question? Should you choose them randomly? Probably choosing them randomly would be best, but you could also just take the first half of the questions and the second half of the questions. But either way, whichever half you pick, they might be a little bit different than the other half, and so you might be seeing a little difference when in reality they all work together very well. So a way to remedy that is with Chromebox Alpha. And that is the most used method. So it's very common. You'll see it written as an R. So Chromebox Alpha, oh no, sorry, you won't see it written as an R. It will be a little alpha symbol. And we will talk about these on our measures that we're using for our study. But basically what Chromebox Alpha does is it takes all the numbers here in the Claremont Purpose Scale, it takes all these questions, and it does every possible version of split half. So it has odds versus evens, 1, 2, 3 versus the next 3, 1, 2, 4 versus 3, 5, and 6. So every possible split half, it cuts it that way and it compares it all that way, and then it aggregates all those split halves. So it gives us a score that correlates every item with every other item on the scale. And again, you want a high correlation score here. So you want a Chromebox Alpha of 0.8 or above generally, because that would show that all your questions are very related to the other questions. It is internally consistent. You are being consistent within your questions. And remember again, these are people who just take the measure once, so all this calculation is done on a computer. I mean, you could do it by hand, but that would be a real pain, so I don't recommend it. So again, I'll show you this example of the split half. So split half is where you take half of the questions, compare that score to the other half of the questions. Chromebox Alpha takes every possible split half there could be. So it takes this split half that we have here, but it also takes 1, 2, 3 versus 4, 5, 6. It also takes 1, 5, 6 versus 2, 3, 4. So it gives us every possible split half. It gives us a number for our alpha. And so that again is the most used method to find the internal consistency and reliability of a measure. Because you're only measuring people once, it's measuring it compared to all other scores. So each of these items, so each question is called an item. So I know it gives my life meaning, that's one item. My life has a clear sense of purpose, that's another item. And then the last one I wanted to talk about is inter-rater reliability. And so here I want you to watch this final video down here. So you can pause this video right now and go on, well, let me finish introducing it. And then you can go and watch the video. So essentially what you will see here is one child that is in a reading program. I think they're speaking French and he's reading French. But basically he's trying to read a paragraph, and there are 3 teachers or 3 raters there that are marking whether he got words correct or incorrect. So with that, they're using a computer system so they can mark which words they thought they got correct. So you'll be able to see their screens where they mark a red mark. So the reason 3 of them are judging it is because they want to make sure they're getting a consistent measurement across all three of them. You'll see from their screens that not all of them score everything as a miss. There are some things that everybody scores as a miss, but there are some things that only one or even two score as a miss. So by doing this, by having multiple raters, it allows you to get a more reliable measure of what is correct versus incorrect. So let's say you were getting your final exam graded in this class. I could grade it, and that's great, but it would be better for rater reliability if I also took maybe 10 of them and had another faculty member grade those and see if I got the same grade as that faculty member. And then I could know, oh, am I being too hard on the students? Am I being too easy on the students? It would make sure that we are more consistent across the department with our grading. So that's what you'll see. Go ahead and go watch that video now. And hopefully you will see that as an example of how to do inter-rater reliability. Multiple raters looking at reliability. All right, so hopefully you've watched that now. You've clicked on that link and you've gone and watched that. Hopefully you see that as this child made a few mistakes, on some of those mistakes, everybody put a red mark. But on some of the mistakes, only one or two of the raters put a red mark. So when that kind of thing happens, the raters will look at their scores together and say, oh, you saw this one. Well, he said that right. He said this. You must have misheard it. Or they can talk and be like, oh, you're right. I missed that one. That one should have been marked incorrect. So it gets you a more reliable, a better measurement of, going back to this, your observed score from 3 raters is more representative of that child's true score, and they've shrunken that measurement error because they're getting at the true score of how well that child did on that test or on that reading paragraph, and they have deleted some of the measurement error because they, as humans, are making errors in their measurement, in their judgment. So hopefully you can see back to this reliability graph. You're trying to get whatever your observed score, so that child maybe scored a 96%. You want that observed score, 96%, to represent a true score of 96%. So you're trying to use multiple raters to take out that measurement error. When you're thinking about test-retest reliability, you give them one test and then you give them the same test again, or maybe you give them alternate forms of the same test. That is to make sure that your questions are getting very little error and more true score. So whatever you're observing, it's not changing. That's why it should be highly correlated with the previous test. So your test 1 and test 2 observed scores should be nearly the same. And same thing with internal consistency reliability. When we're talking about split half, the scores on this first half should be very similar, if not the same, as the scores on the second half. So you want to be consistent with your measures. That's what reliability is all about. Next time we are in class, we will talk about validity, different types of validity, like construct validity. We will talk about face validity and convergent validity, discriminant validity. There's a whole lot of validity. But remember, reliability is about consistency in your measurement. Validity is about truth or accuracy of your measurement. So are you getting at what you wanted to get at? Reliability is, are you measuring consistently? Is your measure giving you the same score again and again and again? Validity is, are you measuring what you think you're measuring? All right, so I will give a little bit of information about lab in part 3 of this video. So stick around if you are in lab. If not, feel free to take off, and I will see you Monday. And have a great weekend.